In this video, we'll be talking about ways of representing sets and the properties of sets. Okay, the first method we'll be talking about is the listing method. In this aspect, all you have to do is just to list all the elements of your set. That is, if you have set A to be 1, 2, 3, 4, and 5, I can say this one here is a set because it have an element that belongs to it, and it is a listing set because we list what all the elements of the set. If you have A to be 4, 6, 8, 10, this one is still what under what listing method. The second method we'll be talking about is called the set builder notation. Talking about the set builder notation, the first thing you need to know is the type of numbers that we have: the natural number, the rational, the integers, the complex, and the real number, because you are going to need them in representing your set. Okay, let's assume I want to rewrite this set here in set builder notation. First of all, I need to know the part of numbers that this element belongs to, and to have the final answer for that, I can say this belongs to natural number, or it belongs to the positive integer, that is the positive integer or the natural number. Okay, now let's say you want to rewrite this in set builder notation. The first thing you need to do is that you refer to every element here as x, or any variable that you want. So I can refer to it as x such that, that is the symbol for such that x is a member. You now pick, is it a natural number or integer or complex or any type of number it is. So from here now I can say x is a member of what? Natural number, comma, then I'll pick their range. The range is either between 1 less than s less than equal to 5. It is 1 less than equal to s less than equal to 5. Okay, another way that you can use to write this is that you can say your A is s such that s is a member of natural number, comma, and the range of the number is 0 less than s less than 6. That is another answer. Another one you can try to write is A to be s such that s is a member of natural, comma, the range can change to 0 less than s less than equal to 5. Okay, another one you can use to write is that A is x such that s is a member of natural number, comma, 1 is less than s less than 6. Every representation here is correct depending on the range of values that you have. So that is how to write your set builder notation. Imagine you want to write something of this nature in set builder notation. Let's say you have A to be 2, 4, 6, 8, dot dot dot. This one is a continuous set, that is an infinite set. If I want to write the set builder notation here, it will be a to n such that n is a member of what? Natural number. And I will end it here. A is equal to 2n such that n is a member of what? Natural number. Okay, don't forget that natural number is what? Starting from 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. So if I want to get the element of this set now, I can say that A equal to, if n equal to 1, n cannot be 0 because this is natural number. If n is equal to 1, that will be 2 times 1, we have 2. Okay, if n equal to 2, 2 times 2, we have 4. Okay, if n equal to 3, 3 times 2, we have what? 6. If n equal to 4, 4 times 2, we have what? 8. If n equal to 5, 5 times 2, we have what? 10. Like that, like that. So that is how to get your set builder notation. Okay, so let's talk about properties of set. The first property we want to talk about is called union of set. Union of set. Okay, union is the combination. Let me write it down. Combination of two or more sets. Union is the combination of two or more sets without repetition. And the symbol for union is just like this. This is the symbol for union. Okay, let's say you have set A to be 1, 2, 3. Okay, and you have set B to be 1, 4, 5. Okay, and you want to write A union B. Your answer there will be 1, 2, 3, comma. There is 1 here again in your B, but so far there is 1 here. You don't need to write the 1 here again. So it will be what? 4 and what? And 5. That is A union B. Without what? Without repetition. Note that A is a set, B is a what? A set, and even A union B is a what? Is another set on its own. Why? Because it has a particular element. Now let's reason something here. I want to show you something that will help us. Let me clean some space here. I want to show you something that will help us when we get to set proving. It will really help us when we get to set proving. Okay. Now recall that A is 1, 2, 3. Abi? Okay. B is 1, 4, 5. A union B is 1, 2, 3, 4, 5. Now from here, imagine that we don't know A and B. Okay, let's assume that we don't know A and B. Let's clean them. Let's assume that we don't know A and B. Let's clean them. I want to show us something important here. Now let's imagine that we don't know A and B. Okay, then I can say that 1 is a member of A union B, right? Which implies that 1 is a member of A or 1 is a member of B. Okay, 2 is a member of A or 2 is a member of B. Okay, 3 is a member of A or 3 is a member of what? B. Okay, 4 is a member of A or 4 is a member of B. Because we don't know A and B, that is why we are using OR. If you check actually what is your A and B, let's come back here. You will see that 1 is a member of A and also 1 is a member of what? B. But in this case, 2 is a member of A or 2 is a member of B. You will see that one of it will be correct. Is either one is correct or both is correct. I get my point now. Is either one is correct or the two are correct. So you see that 2 is a member of A implies that 2 is a member of A, that is 2 belongs to A, or 2 is a member of what? B. We are using or because we are not sure if it belongs to A or B. Remember that we assume that we don't know our A and B. We only know A union B. That is why we are having or. The second property that we want to talk about is union of a set. Let me clean the whole of this so that we have more space to work. Let me clean this. Alright. The second one we want to talk about is intersection. Now, we're talking about intersection of a set. Intersection, it deals with common element between set A and B. Note that intersection of a set is a set on its own too. Note that. The symbol for intersection is just this one. This is the symbol for intersection. Okay? Now, let me use another color here. Now, let your A to be 1, 2, 3 and let your B to be 2, 4, 5. Okay? A intersect B. We need the common element between A and B, and that is just what? 2. Okay? If you have A to be 1, 4, 5 and you have B to be 6, 8, 9. If I want to find A intersect B, I need a common element between A and B. You will see that this will just what? Empty set. You can write your empty set like this or just this. So that is one important part that you need to know about set theory. Another important part here is that you will see that we're talking about A intersect B. It simply means that 2 is a member of A and 2 is a member of B. You will notice that we are not using or again. We are using or just because we are not sure where the element belongs to. Either it is A or B. But here we are sure that it belongs to what? Both A and what? And B. Okay? The next one we want to talk about, which is the number 3, is called the empty set. When talking about empty set, I've already explained it here. Empty set is just a set without what? Without element, and these are the symbols for empty set. Let's move to the next one. We call it universal set. On this universal set, I would like you to meet me in the next video so we can talk better on universal set. Thank you.